Okay, so today technically is not the review for the graphing test because we already did the review for the graphing test, and that was on Friday. But the graphing test is tomorrow. Why am I not reviewing for it? Because we have another test on the next day, on Tuesday, that's about communications. So I'm going to do a little bit of graphing review because it is the test that's tomorrow, but I'm going to spend the majority of my time today helping you get ready for a test on communications. Communications number 3 to be exact. All right, so what the heck does communications mean? That means communicating about math. Like for instance, saying the limits. That's a big part of what that test on communications is about limits. So if you've got all those kinds of end limits figured out, then you're going to be in great shape. For right now, though, I'd like you to try this one. It's just a simple little graph that's been moved. If you know what the parent is, because it's got a squared and the denominator, 1 over x squared to be the parent. And by the way, just to keep anybody from doing this all wrong, what is the parent on this one? The volcano. Very good. Look, it's even making a volcano. Okay, so the fact that it's even in the denominator, like x squared, as opposed to if it was odd, if it was like 1 over x to the third, then it would make that one. But anyway, we're doing the volcano one. So obviously, start with that as like your paradigm. It's going to generally look like this. I'm going to throw in one more thing. I'm going to throw a negative on top. I hope you know where that's going to make it flip. I'll pause for a second while you try that one. So here's how you should have done this one. First of all it would take is one little false move, like, ooh, I flipped it the wrong way. And you'd never know unless you checked it with an XY chart. How many of you remembered to check a point or two? All right, 4 people. So that means that you're missing a chance to keep yourself from making that mistake on the test. Remember, the XY chart knows all. It can do everything. All right, so I'm going to go and make it without the XY chart first and see how well I do. Would you agree it generally starts here and goes through this important point and that important point? You with me so far? Okay, and now do you agree that generally these have asymptotes and they kind of run like this and like that, right? Now where should I move this thing because of that plus 3 there? What does the plus 3 do for it? Left 3. So I'm going to move everything left 3. 1, 2, 3. And then that means the asymptote needs to move left 3 also. The other asymptote, if I move it left 3, you won't even be able to tell because, it's this way. So how about that minus 1? What do I do then? Down 1. So this goes down 1. It's down 1. Good. Now can you see how some kid could get to this point and go, yay, I've got it right, and have made a tragic mistake? How could you have caught that mistake? The XY chart would have caught that mistake. Okay. So I'm going to show you how you could keep yourself from making a mistake like that. So I'm now thinking that I've got the right answer. I know it's not right, but then I go over here and I say, okay, well, it looks like if I put in x is 2, that I ought to get 0. So I put in a 2. 2 plus 3 is 5. 5 squared is 25. What the heck is going on? I don't get anything close to that. You see what I mean? So that's telling me, oh, something's tragically wrong. Okay, so I'm going to go back in time and say, what should I have done first? Yes, reflect. Now, you didn't have to do it first. I could have reflected later, but I like to do the reflections at the beginning because it's so much easier to reflect when it's like this. Because see, then this point just needs to go there and there. Okay? Now I'm going to remove these guys. Okay, now I'm going to do the shifting and sliding and stuff. This is going to go 3 to the left, so that goes 1, 2, 3 over. So then these guys go 1, 2, 3 over. And then the minus 1 means down 1. So now I'm going to move everything down 1, down 1. And there we go. Now, can you see any mistakes in it now? Okay. So now, if I put in, I just realized I tested that other point wrong, but it was still going to be a wrong was still going to be a wrong answer. Okay, anyway, I should check here, and x is -2. That's why the other point wouldn't work no matter what. But anyway, put in a -2 here. -2 plus 3 is 1. 1 squared is 1. -1 divided by 1 is -1. -1 minus 1 makes -2. And look, -2 is on my graph. I am doing it right. Okay, should you automatically, if you check one point, assume you screwed up? No, you should probably double check, maybe the other point's right or something. Maybe you made a mistake in your first point. That's -4. If I put in a -4, I'm probably going to get something similar. -4 plus 3 is -1. -1 squared is 1. And then it's -1 over 1. And that makes -1 minus 1 is -2 again. Is that right? Yeah, look at that. -4, -2. It's on my graph. Both points are on the graph. You know you did it right. Okay. So there's a reminder of a graphing question. All right. So how is communications different? Communications is more about limits and stuff. I'd like you to take that same idea of a graph, the one that was like this, and I'd like you to tell me what the 4 end limit. Actually, I should clarify this. There's end limits, which are way out here, like left end and right end, and the other ones are not end limits. The ones that are on the inside, they are limits as you approach its asymptote. So I'm going to draw you a much cleaner, nicer graph here, and ask you for the limits as it approaches its vertical asymptote. I'm going to draw it here. Please note that I'm doing it slightly different than I had a second ago because I've shifted it all to the left. Okay, so now let's say it's like this. And let's say it's like this. Okay, new graph. Tell me what the left end limit would be for this graph. The left end limit. Write it very carefully. I'm going to have you compare with the person sitting across from you. These two rows are going to compare, but you guys got to go kind of diagonally. See what I mean? You're going to have to compare with him. Okay? And your two rows, and let's see if diagonal would work. Nope, just go straight across. For today, you compare with the guy on the very end there. You're just going to have to like slide a little left or right so that you can see hers. Okay? And then you two are comparing, and then it's everybody across from each other here. Okay? Get your left end limit done and compare with the person I paired you with. Okay, we're back. And the left end limit. All limits look like this. Lim of the function as x approaches. And then you say equals. Do you get that every single limit you ever write will look like that? Then it has to have the x number here. And if you're on the left end, think about where x's go to the left. That makes -infinity if you go way to the left. Okay, how many had that right? Right. Okay, good. And then when you get there, remember that this is the y number, which is also the height of the graph, because that's what y's are, is how high they are when they get there. This one is rising, but it's going to an asymptote, so it's getting closer and closer and closer to a height of 0. Raise your hand if you had that perfect. Okay, good. Now, that's the easy kind of limit. The other kind of limit is a little more tricky. They're the limits of this function as it approaches its vertical asymptote. Now, first of all, you got to ask yourself, what's the vertical asymptote? That's this. So as it approaches that, is x approaching infinity? No, x is approaching this dotted line right here, which is at 2. Would you please write me the limits as it approaches its vertical asymptote? And there's a left one, and that does not mean the left end. That means the left of these two limits. And then the right one as it's approaching its asymptote. We're not over here and we're not over here. But there is a left side and a right side of the asymptote. Okay, I'm going to pause while we try that one. Those two, actually. Okay, let's see how you did on those. Would you compare with the person sitting next to you, please, first? And compare your left one with them. So I'd say this is probably the hardest thing to get across to people, and I know it can be, stressful for you to try to understand. But remember that the things you do know that it starts with lim of the function as x approaches something, and it has to equal something. Remember, that's of course an x number, and that's of course a y, or a height. If you keep that all straight, it's not that bad. If we're approaching the asymptote is here at 2. So we have to be approaching 2. Is that y equals 2? No, that's an x thing equaling 2. You're approaching 2. And then you're either approaching it from a minus or a plus. From the x's that are negative would be over here. That's from the left. So left goes with negative and right goes with positive. Then you say the height when you get there. If I'm coming, in this part you actually have to use your pencil or something and go, if I'm coming from over here, where would I be forced to go? And you get on this railroad track and you'd go down there to negative infinity. Because the height, if you got infinitely close to this asymptote, is going to be infinitely close to negative infinity. The right side, lim of the function as x approaches, well, what am I approaching again? I'm approaching the asymptote, which is x equals 2. And I'm approaching it from this side this time, which is from the positives. And I would be forced onto this track right here, positive infinity. Do any of you want more review on that topic? Okay, remember you can always ask me privately for more help on that. All right, next thing, communicate with me. Tell me in this equation what should be done first, second, third. There's 3 things that are happening to my volcano. And there is more than one possible answer, but that does not mean that anything goes. I'll pause for a second while I try. Okay, I like if you start on the inside. You don't have to. It actually sometimes works better to start on the outside, but I would start on the inside, which would mean right 4 is a good first start. Then, what is on the outside? I know this seems weird, but that negative and the 2 are both on the outside. Let me prove it to you. If I put the negative 2 like this, and then put 1 over x minus 4 squared, now it makes it really obvious that negative 2 is on the outside. Do you get that's how it would work? Because if you multiply it in, that multiplying would be over 1, and that would go into the top then. So that stuff on the top is really on the outside. Okay, so what does that mean? That means the stuff on the outside has to be done in the opposite of normal order. Well, there's really only 2 things, and they're both multiplies. Multiply by a negative 1, which makes it flip, and then multiply by 2, which makes it stretch. So does one of those 2 have to go before each other? No, it can either way. It's actually fine. So it would have to be, I personally like to do stretch before you flip, okay, because it works for gymnastics, and frankly, it's a little easier in the, if you stretch them before you flip them, because the stretching is the hardest part, and if you start with that on the graph, it's the easiest. Anyway, I do the stretch first. So that would mean vertical, stretch, factor 2, and then the flip, which is the vertical reflect. And no reason to try to say over the x or the y, because you're just likely to screw it up. That is the most commonly marked wrong thing, is when I have kids try to tell me it's going over the x or over the y-axis, they get that x or that y wrong. So don't. Just tell me it's a vertical reflection or horizontal reflection, and that's good enough. As long as you got your vertical and horizontal straight, you're fine. Okay, vertical is up and down, right? So you can always, if you have to, think yourself through it. Up and down means this way. Which did I just go over there? The x. But I'm telling you, so often, I mean, the fact you had to ask meant you weren't sure. So obviously, you shouldn't go with your gut and say, okay, I'm going to go with the x-axis, because you're just doubling your chances you're going to get the problem wrong. Because if you're not sure, stick with vertical and horizontal. Okay, because that's on the outside. Stuff on the outside is vertical, high vo. Horizontal stuff is on the inside, vertical stuff's on the outside. All right, next one, I'm going to give you some directions and I want you to make me an equation. If the parent is the 1 over x graph, then I want you to make me one that's had a vertical stretch factor 3 and a horizontal shrink. I can't spell shrink. S-H-R-I-N-K. Factor 1/2 and a left 5. Write me the equation for that. Okay, start with the y equals 1 over x with plenty of room around it so we can make some changes. Okay, vertical stretch factor 3. Could you put the 3 on the outside? Yes. Could you put the 3 on the top? Yes, they're the same thing. Okay. Horizontal shrink factor 2. That's on the inside with the x. So in here with the x then, we want to have a shrink factor of 1/2. Don't put a 1/2. You put a 2. Okay? Because that's counterintuitive in there, and it seems like it'd make it twice as wide, but it actually makes it half, and therefore it works to have a shrink factor of 1/2 is really a 2 when you're on the inside. And then left 5. Here's a really, really, really common mistake. Left 5. They go plus 5. There we go. I'm done. What did I do wrong? I've marked this wrong more than any other thing on this kind of problem. Nobody said it yet. Okay, first of all, there's nothing on the outside. There's no squared because this is not a volcano. The parent function is a 1 over x, so that's not the problem. There's no parentheses. You got it. It needs parentheses. Where? Right here. Remember that part? The most commonly marked wrong part of this question when I gave it to you on the last test. So of course you're still having trouble with it now. I'm not surprised. It's really easy to forget that. Okay, so let's do, I don't think we need to do another. Do we need to do another like that? I can if you want. Seeing lots of head shaking, no. Okay, I will do one for you if you want me to. You just ask me during work time. Okay, next topic. Let's talk about a big old equation. In general, when you're sketching these, what part don't you care about? Yes, the flyover country. Very good. It's this area. Okay, we don't even pay attention to that. We pay attention to this. That tells us what? That little negative sign or positive sign tells us what? Where? The right side. It tells us that it's down on the right because there's a negative in front. This little 3 right here tells us what? Opposite. Exactly. Don't think up or down. Think odds tell you opposite. Evens tell you that they're going the same direction as this first one. Well, the first one's going down, so the opposite of that, this must have been going up. Odd ones will always be going in opposite directions as each other. Then we look at that and say it has to go through positive 5. There we go. Now, is what I just graphed there possibly the graph of negative x, 6x to the third, blah, blah, blah? Yeah, it's possible. Now, the mistake kids make is they'll try to get fancy and go, well, it doesn't even matter what I do in here. And then you just got it wrong because if it has lots of turns, you can count them and say it's at least, well, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 turns, and therefore it's at least, this one would be at least degree what? 9. Okay, so don't get fancy throwing in a whole bunch of turns. Can it have less turns? Yeah, because, for instance, that could be x to the 8th. And it's only got 1 turn. So all we'd say is since it's got 1 turn, it's at least degree what? 2. But could it be degree 8? Yeah. All right. So don't throw in a whole bunch of extra curvies on them unless they justify it, or you have a justification for it. All right, so let's say we had this. What's if it's factored? In factored form, you know so much more. And let's just throw in an X in front, because that definitely adds to the challenge, because a lot of people don't know what to do with it. All right, make me a sketch of that one. If I were you, one of the first things I would do is figure out the lead coefficient, and I'd also figure out the y-intercept. You remember the flyover country thing? We need to figure out, what does this start with? I don't care what the flyover country says, and how does it end? You can get that by looking at this equation, and once you've got that, it helps you a lot for making your graph. Pause for a second while you try that. All right, remember that the goal here is to write a graph. This is a good start because it tells you some stuff about your graph, but I want you to actually make a little graph. And on this kind, we would expect you to know what the roots are, as in where it touches the x-axis, and how it touches the x-axis. That all has to be factored in. So you can't just say, oh, I know it's going up on this end and up on this end, and I think it goes through here, so there. No. You have to be much more accurate on this kind because it's been factored. All right? I want you to see if your partner, if they're done, give them a chance to finish, but see if yours and your partners are similar to each other. Check your roots, see if they're bouncing the same spots as yours. I'll pause while you try that. Okay, let me tell you what I know about this one. First of all, this x, would you agree that that's x to the 1? And this is x to the 1, but then it's squared. So that makes this really x squared times this x makes x to the 3rd times one more x makes x to the 4th. And you get there's no negatives on any of these, and therefore it is positive in front. And then, how do we get that last number? You got to think what it is. Isn't that last number the y-intercept? So let's finish this sentence. The y-intercept is where, what? X equals 0. So then you can put in a 0 on this whole thing to figure out where, hold on, got a marker missing here. So if I want to find where the y-intercept is, I can put in x equals 0. So I put in a 0 here and here and here. But if I multiply 0 in the front times anything else, it doesn't even matter what these are. The answer is going to be 0. So this last number is a plus 0. So I hope you know that this graph has to go through here, and it's even, so it has to be going up and up. Are you with me so far? Now you have to double check things like, I know what all the roots are, and I know what it's doing at those roots. The root here is a -3, so it better be touching at -3. The root here is a 0, so it better be touching at 0, and then a root here is 4, so it should be touching at 4. So now how can I make that happen? Oh, and it's bouncing at this root. It's bouncing at the 3. So if it's touching here, bouncing there, and going back up through here, there's the possible answer. Oh, what do you think's wrong with it? There has to be a bounce at -3. Oh, okay, so I bounced where? I bounced at 0. Is this thing squared? No, so that didn't work. Okay, so I better try that again. Cut through, cut through. There we go. No. What am I supposed to do with the -3? Bounce. Okay. How about now? Cut through, bounce. There we go. Does that one work? Okay. Notice it has a y-intercept of 0, and it had been bouncing at the -3 because of that 2 right there. And it goes through the 4 right there as a cut through because it has a power of 1. All that making sense to you? All right, then fill out this little chart for me. If this is my equation, what are the roots? There's 3 of them. What is the multiplicity of those roots? And what does it do at those roots? Bounce versus cut through, etc. Hardest one first. I'm going to put a parenthesis around this just so you can see it acts like all the other ones. It's a root. There's an X in there, so there's a root there. And its root is 0, because the 0, if I put a 0 in, that's what would make that whole parenthesis equal 0. The multiplicity there is the degree, and that's a 3. What does a 3 do? It snakes. So my graph would have to snake through at 0. Okay, next, -2 is the root for this part, and it's a 2 for multiplicity, so that's a bounce. And the last thing is this is a root of 1, and the multiplicity of that is the little number at the top. It's a 1, and that's a cut, and you can just say cut instead of cut through. You can abbreviate that. Okay, last thought. What's the degree of the entire polynomial? And don't say 3, because that's the most common mistake answer. You know what the next most common mistake answer is? Yep, 5, because people don't think about this 1 as being there. So they go, oh, 3 plus the 2 makes 5. Nope. 3 for 5, 6. Did you have 6 in your mind? Good, because that's what degree this polynomial would be. And that's an even, and that makes sense because it would be either up on both ends or down on both ends. The lead coefficient is positive, so it has to be up on both ends. It would have to be snaking through at 0 and touching at negative, this is supposed to be a 2, touching at -2 and touching at +1. So it'd be cut through, snake, and then cut through at the end. Oh, that doesn't make sense. Oh, yeah, you're right. It's supposed to be bouncing at -2. Bounce. Snake. Very hard to show that that's a snake. And then I cut through at the top. And if you're having trouble drawing it, you write in snake for me on a sketch, I could accept that. On a graph, I couldn't. But okay, you have to get close. This one actually is pretty close. What you want to be doing is, like, going from here to here, it's got to be decreasing the whole time. And it's got to change from decreasing at an increasing to decreasing at a decreasing. Whew. Snakes are tough to describe, but... All right. That's not everything, but I can't possibly do everything. I'm pretty much out of time. So I did a bunch of review for you that should help on both tests. You have 2 tests in a row now. Tomorrow and the next day, 2 tests. Your review packet, hopefully you've already done much of it. Finish it, check it. Hopefully you rock the next couple tests. That's all I have for you for today.